back to Ballard's class.
Okay. Alright, so how do you integrate an exponential function is what we're going to deal with today. I don't know, is that filled in for you? You got to fill in. Fill in? Okay, fill it in. It should not be a surprise that e to the x is, the integral of it is e to the x plus c, of course. The u's mean I could have some U-substitution going on, which we're pretty much going to see in almost every problem, because e to the x is just too easy. Okay, so let's try it out. What do you think we're going to use as our u? 3x plus 1, good. Okay. So u equals 3x plus 1, so that means that du equals 3 dx. I'm missing the 3, so what do I have to do? Move it over. Okay, so now let's go ahead and sub in. We get e to the what? U. Alright, and then for the dx I'm putting in 1/3 du. When we integrate e to the x or e to the u, we get e to the u plus c, and then we have to sub back in for the u. What am I subbing back in for the u? 3x plus 1. And probably after we take our test on Friday, I will probably start going from here to here. Okay, I'm going to probably skip that intermediate step because we can pretty much see what the u is going to be, unless it's something really complicated. Yes, CJ?
I don't get how this changes anything. Adding u's in instead of just doing it.
What?
I don't get how this changes anything.
It didn't really. What do you mean? For integrating e to the x? It's just that's the way it is on e to the x. Okay? Alright. Let's try it again. Be thankful it's easy, right? Okay. Let's look at u. So what do you think you're going to use as u this time? Good. So write that down as your u while I'm getting back here. Alright, so u equals negative x squared, which means that du is equal to what? Negative 2x dx. Look, I have the x dx. So I need to move the 2. How do I move the 2? Divide by 1, negative 1/2, or multiply by negative 1/2. Sorry, not divide. So I'm going to go ahead and sub in. Where's this 5 going to land?
Right in front with the 1/2, so make it 2.5.
Better yet, make it negative 5 halves. Okay. For the negative x squared, we're putting in the u. For the x dx, we put in the negative 1/2 du. I kind of already put in the negative 1/2 part. All right, when we integrate e to the u, what do we get?
Negative 5/2 e to the u plus c.
Plus c, and then what are we putting in for the u? Negative x squared, good. All right, let's take a look at example 3. What do you think your u is going to be this time? Nope. 1 over x, which is really the same as saying x to the... Actually, yeah, x to the negative 1 when I go to take a derivative, right? That's okay for derivative, not okay for integral. No, because remember that's... No, that's integral. Okay, derivative, we'd use this. All right, so when I take the derivative, where's this going to land? In front, so negative, technically 1, x to the what? Negative 2 dx. Now look at what I ended up with. I really have negative 1 over x squared dx. Do I have 1 over x squared? Yeah, what am I missing? The negative, so I got to bring the negative over. Whenever you see that 1 over x and you see an x squared in the denominator, that it's going to all be taken care of with the u. All right, so let's go ahead and sub in. So for the 1 over x, we're putting in what? U. 1 over x squared dx, we're putting in negative du. All right, I go to integrate. I get e to the what?
1 over x.
No, e to the u plus c. And instead of u, we're going to write e to the 1 over x plus c.
Cosine of x is the integral cosine of sine.
All right, we good with 3? All right, what are you going to use as your u in example 4? Cosine x. Okay, so du is equal to what? Negative sine x. So not just do you need to know all your new derivatives and integrals, you need to make sure you know your old ones too, because they're going to still pop up. Okay? I'm going to go ahead and move the negative over. So negative du equals sine x dx. All right, let's sub in. So for the cosine x, I'm putting in what? U. And then for the sine x dx, I'm putting in negative du. So when we integrate e to the u, we get negative e to the u plus c. And for the u part, I am subbing in what? Cosine x plus c. All right. Let's see if we can make it a little bit more interesting on the next couple here. All right. Looking at this one, what do you think your u is going to be this time?
2x.
It's not 2x.
It's e.
Nope.
E to the 2x.
1 plus e to the 2x.
Either way.
Okay? Because look at what you're really looking at integrating is probably more of a natural log than the e. Okay? The e is embedded inside. Because what's the derivative of e to the 2x? And we have that, right? So it's appearing there, so it's going to be part of a u thing. All right, the 1 goes away. You told me it was e to the 2x, and then the chain rule gives you what? 2 dx. So which part am I missing? I'm missing the 2 because I have the e to the 2x dx. So I'm moving over a 1/2 du equals e to the 2x dx. Okay, now let's sub in. The denominator gets u. The e to the 2x dx gets 1/2 du. Okay, so now you got to think about what we did last week and the week before. When we integrate 1 over u, what do we get? Good. And then for the u, what do I get to put back in? Good.
How do you tell your absolute right value?
I try to make the absolute values longer than my ones. Okay. All right.
You want to test?
Let's try another one. This next one has a little bit of a trick to it. Okay. Before I take my u, I'm going to do something. What do you think I could do with that numerator first? Let's take out a 2. Okay. So we have e to the x minus e to the negative x over e to the x plus e to the negative x squared dx.
Can we make that like a different thing and then...
No, we're going to use a u. Okay? Just trust me. Okay? All right. So I've got a funky squared thing in the bottom. So which one of those do you think is the u going to be? The bottom one. So e to the x plus e to the negative x. Now let's take the derivative of that. So what is the derivative of e to the x? E to the x, and the derivative of e to the negative x is? And then the chain rule gives me what? Minus. So does that look familiar? Isn't that the numerator? It is. All right. So the 2 is going to hang out. For the denominator, I'm putting in u. For the numerator, for the e to the x minus e to the negative x dx, I'm just putting in a du. if I had worked a little smarter, I would have probably just written that. All right, I'm going to integrate, which means I am adding 1. So when I add 1 to that, I get 2 to the what? 2u to the what? Just the first? The negative first plus what? Let's see. Okay, and I'm going to do 2 things at once. Okay. So I'm going to not only move my u downstairs, but I'm going to sub in for it too at the same time. So I'm moving that downstairs and subbing in the u. Plus c. I probably don't need the parentheses. All right, let's look at 7. All right, we only got 3 left. Oh, we got plenty of time. Okay, so let's look at example 7 here. I've got, what do you think you're going to use as your u? How about just negative x? So du is equal to negative what? Negative dx. Okay, so I'm going to move my negative over because that's what's missing. All right, I am going to, on this one, there's 2 ways that we can do it. We can sub in for the u, or we can ignore our limits till we put our x back in. That's what I'm going to choose to do on this one. Okay. So I'm going to ignore the limits until I get it back in x's. So I'm going to go e to the u, and then for the dx, I'm putting in negative du. All right, when I integrate e to the u, what do we get? E to the u, we're not doing plus c, because I had limits, right? So, and I can't put those on there until I convert it back to x's. So, oh, sorry, I'm not doing a very good job of converting it back to x's this morning. Okay, so I'm putting the x back in, so I'm putting in negative x for the u, and I'm going from 0 to 1. So we put the 1 in first, so we get negative e to the negative 1 minus negative e to the negative 0. Okay, double negative goes what? Positive. What's anything to the 0 power? No, not 0. 1. And then is this happy where he's at? We don't like that negative exponent, do we? Negative 1 over e plus 1. It would be a non-calculator problem on an AP test if they give you that. Okay. All right, let's take a look at the next one. Okay, so we're doing a bunch of definite integrals here. All right. So again, we've kind of done one similar to this during this period. What do you think you're going to use as your u? Got to use that whole denominator, right? So we want to get rid of it, because if I just used the numerator, I wouldn't get rid of the 1 plus part. Okay. All right. So du is equal to what? E to the x, dx. Good. And this is another one. I'm going to ignore the limits. I'll put the limits back on once I substitute my x's back in. Okay, because I don't want to mess with putting it in 1 plus e to the x. It's going to be messy. All right. So for the denominator, what are we subbing in? U. Good. For e to the x dx, I'm subbing in du. Good. Yep. So when we integrate 1 over u, we get? Natural log of u plus e. Good. And then for the u, I'm subbing in. Oh, we're not doing plus c, are we? We need, yeah, but we can't put the limits on until we actually have x's back in there. Okay, so I'm going to put that to remind myself. Natural log absolute value of 1 plus e to the x from 0 to 1. So we're going to plug that in. So let's see, we've got the natural log of 1 plus e to the first minus the natural log of the absolute value of 1 plus e to the 0. All right, so let's see what they could do with that. What is anything to the 0 power? So that could be a 1. So this is really the natural log of what? 2. What's the absolute value of 2? 2. And then the absolute value of 1 plus e is just 1 plus e, isn't it? So I can drop my absolute values. Now, they could leave the answer like that, or they could use their algebra. What does subtraction turn back into? Division. So they could go as far as this. So I would take really almost any of the, AP would actually take all 3 of these last answers. Okay. Yeah, really. if it was free response. If it was multiple choice, you got to find the multiple choice answer, right? That's correct. On the upside, AP has yet to introduce those funky multiple response answers like SBAC does. So, okay, looking at example 9. So we have got to, what do you think you're going to use as your U?
E to the X.
Good. So du is going to be?
E to the X. Dx.
Okay.
And we already have that.
Yep. So I'm going to ignore my limits. So I've got cosine of u. And then for the e to the x dx, I'm putting in du. All right. When we integrate cosine of u, I get u. And then instead of plus c, we're going to put our bar because we don't know what the bar is quite yet because we've got to sub back in my x's. So e to the x from -1 to 0. You're going to love this answer. All right, we're going to go negative sine of e to the 0 minus negative sine of e to the -1. Pretending we don't have a calculator, we could maybe clean up some algebra. What's e to the 0? So we've got negative sine of 1. Double negative is going to go positive sine. And then this is going to be 1 over e. That's the best you're probably going to do with that.
Wait, can we do sine of 1 and then make it a 0?
You could put sine of 1 in your calculator, but if you don't have a calculator on this problem,
Equals a negative unit circle. Come on.
That's sine of, that's, you're looking
you
at.
can't find sine of 1 on your unit circle.
You're thinking about sine of pi over 2.
You're right.
Yeah, you can't, you could reverse 1, but you can't find the sine of 1 on your unit circle.